Hi everyone, I'm here to do LeetCode problem number 2843, which is count symmetric integers. Let's read the problem. You are given two positive integers low and high. An integer x consisting of 2 times n digits is symmetric if the sum of the first n digits of x is equal to the sum of the last n digits of x. Numbers with an odd number of digits are never symmetric. Return the number of symmetric integers in the range low to high inclusive. Give me 1 minute. Okay, sorry, I took a short break, but let's get back to the problem. So what's going on right here? You're given two ranges. Low equals 1, high equals 100, and there are 9 symmetric integers between 1 and 100 inclusive of the endpoints 1 and 100. You have the numbers 11, 22, 33, 44, 55, so on and so forth. In total, there are 9 of those numbers, symmetric numbers, and you return 9. Same thing when you take a look at the range 1200 to 1230. There's 4 symmetric numbers, integers, and you return the number 4. So what is a symmetric integer? Well, symmetric integers, as stated right here, numbers with an odd number of digits are never symmetric. So numbers with an odd number of digits are never symmetric. That means that numbers with an even number of digits can be symmetric. Symmetric integers can only be numbers with an even number of digits, right? And what does this say? It's basically saying that for even numbers with an even number of digits, if you split it down the middle, right? Split the numbers down the middle, the sum of the two sides, the sum of the digits along the two sides is equal to each other. So if you split the number 11, 1 equals 1. Split the number 22, 2 equals 2. Same with 33, 3 equals 3. And let's take a look at, these are 2-digit numbers. Let's take a look at some 4-digit numbers. Split it down the middle. 1 plus 2 is 3, which equals 0 plus 3, which is also 3. Split it down the middle. 1 plus 2 is 3. 1 plus 2 is 3. Basically, all of these numbers equals 3, right? This is not a hard problem, but it is a little bit tricky. I had to use a hint to help me get started. But basically, the algorithm is that you're going to loop through the range. And as you're looping through, you're going to have to take each number, check if it's either odd or even. There's an odd or even number of digits in the integer. If there is an odd number of integers, then we continue and skip it. If there's an even, then we do that check that I was just telling you about. We split it down the middle and see if the sum of the left and the right sides equal to each other. So let's get started. That's the basic gist of the algorithm. There's some complications along the way, but we'll figure those out. So constraints. 1 is less than or equal to low, which is less than or equal to high, which is less than or equal to 10 to the 4th. 1 is less than or equal to low, which is less than or equal to high, which is less than or equal to 10 to the 4th. Don't see don't see constraints that are too crazy, but we do know that we're going to have to do the for loop can get pretty unwieldy if high indeed does get to 10 to the 4th. This to me is a this is a math and enumeration problem, I believe. I believe this is a math and enumeration problem. Math and enumeration problem, yep. Let's design the algorithm. Define a variable count that will store the answer the number of symmetric integers found. Loop through low to high, inclusive of the endpoint values. Convert, because these are integers, it's a little hard to do that split and then check if the two sides, the left and right side, their sums is equal to each other. So we're gonna work with strings. Okay, convert each number in the iteration to a string if the string has an odd number of digits. Continue. Else then after that you would call a helper function that will calculate the sum of the left and right split sum of the digits on the left and right split of the string if the sum of the digits on the left and the right split of the string is equal. Increase the variable count +1. Okay, return the count. We're gonna have to define like another helper function that will take a string and calculate a string that consists of characters that are digits and calculate the sum of the digits. So let's do that right now. Let's call it def get sum self n. So what we're gonna do for digit in n, n is a string, right? D equals, we're gonna convert the digit to int. We're gonna return an answer, of course. D equals int of D answer plus equal D, return answer. Okay, let's answer. Okay, so the answer is 0 for the digits in n, which is a string. You convert the digit into an int and then you add it to the answer, which will give us the sum, and over as you iterate, and then you return the answer. Okay, so count equals 0. Let's say that n equals high +1 for I in range low to n. We're gonna have to convert each number in the iteration to a string. Okay, so the n string. How about yeah, n. This is a bad convention. Let me just do this. High equals high plus 1 high. Okay. For the I, right? I as a string. Okay. This is better convention. High equals high plus 1. I is the variable that you're going to use to loop through the low and the high range, and then I'm going to convert it to a string, right? I string equals str of I. And then we're going to do, how about n equals len I string. Okay. If n, how about this? I would like to do this. If n divided by 2 does not equal 0. If n divided by 2 does not equal 0, I'm going to cast this just in case. If n divided by, so we know that the string itself, the digit itself is odd, so we're going to do continue, right? I string equals string if n equals 2. If int n divided by 2 does not equal 0, that means else. We're gonna do if get some. Okay. Else we're gonna have to do how about this? M equals n int n divided by 2. So that gives us the split mark, and then we do an if get self dot get sum of the string I string of 0 to m equals self dot get sum of I string 0 up to m, and then I think it's m to the end. Then you do count plus equal 1, and then you return count. Okay, let me take a look real quick. Count equals 0. High equals high plus 1. For I in range low to high, I underscore string equals string. Okay, that makes sense. N equals length of the string, right? If int n divided by 2 does not equal 0, continue. Okay, this makes sense. 4 divided by 2 is 2. It does equal that. 3 would trigger this, right? 4 would not trigger this, and it would go to the else statement. M equals int n divided by 2. Okay, that makes sense. If self dot get some I underscore string to m, and then get some self dot get some I string to from m to yep, this should make sense. This should work. Let me try it. Sorry, made a mistake right there. Hang on, let me check what's going on. Okay, I made a mistake right here. So this is not how you check whether whether something is odd. It's actually, this is a rookie mistake. N mod 2, right? N mod 2 does not equal 0. Let's take a look at the run. Okay, that's good. Okay, very nice. In other situations, it's run a little bit faster, but I I'm gonna try one more time. The time complexity is O of n times m, where n is the number, the range, the number of values that you're looping through from this low to the high, the range of it, that's n. And m is accounting for this for loop that you're doing for the digits of each each string. So the digits as you convert the numbers to a string. So m is actually the biggest number within the range with the most digits, right? So it's n times m, where n is the number of values that you're iterating through in the range, and m is the digit that has the most number of it is the number that has the most number of digits. That's the best way I could explain it. And so space complexity is O of 1. Try one more time. The memory is not very good. The runtime is okay. The memory is not very good. So, but anyway, I'm gonna go with this solution because I came up with it myself, and so hope you learned something, and I'll thank you, and I'll see you at the next one.